Hello and welcome back. In this video we're going to take a look at the Taylor series generated by the function 1 plus x to the k. This will be called the binomial series. Binomial because we have a two-term polynomial here. The 1 plus x is the binomial here that we're raising to the kth power. You might remember we had this binomial theorem which tells you how to expand binomials, how to raise a plus b to the nth power. So here the binomial is the 1 plus x. Now the interval of convergence of this series will be -1 to 1. And we're not going to go through the details about how to find the binomial series, but just to give a little bit of intuition, if you think about the derivatives of this function, basically the k's will keep multiplying in front. You'll get a k multiplied in front. You'll get the next exponent, when you take another derivative, the exponent will again multiply in front, only this time it'll be a k minus 1 that multiplies in front. And then a k minus 2. Every time you take a derivative, you're subtracting another one from the exponent, but you're also multiplying that exponent in the front as well. So that explains the k times k minus 1, the k times k minus 1 times k minus 2, because each of these coefficients are gotten by taking the derivatives of the function and then plugging in the center, which in this case it looks like is x equals 0. So you end up with just those coefficients that are coming from those exponents multiplying in front. K, and then k minus 1, and then k minus 2, and so on. And so the binomial expansion looks like this. 1 plus kx plus k times k plus 1 over 2 factorial x squared plus k times k minus 1 times k minus 2 over 3 factorial times x cubed. Hopefully I said k minus 1 for this and not plus 1. And so on. Every time you're going to get another k, like a k minus 3 for the next one, over 4 factorial, and then x to the 4. One thing to note is that you're going to have as many factors on the top as your factorial on the bottom, right? So if this is a 2 factorial, you'll have 2 of these factors on the top. If you have a 3 factorial, you'll have 3 of these factors on the top, starting with your exponent k, whatever that is, and just going down. Now the crazy thing is that this is going to be true no matter what k is. K can be any real number here, and this will still hold to be true. So it could be a fraction, like a half. It could be a negative fraction, like -2/3. It can be any real number, and this will still apply. One other thing too is that there's a shorthand for these kind of coefficients, the coefficients to each of these terms of the binomial series. And that's k choose n. This is the same kind of notation that you use with the binomial theorem. And when you try to look at what are the coefficients of each term of the binomial expansion, if you expand a polynomial or a binomial. So here, k choose n, for k being any real number, can be written like this. It's k times k minus 1 times k minus 2 all the way down to k minus n plus 1. And that's going to be taken over n factorial. And just as a reminder, so here you're going to have as many factors on the top as your factorial. So here on the top there are going to be n factors on top. So k is factor number 1, k minus 1 is factor number 2, and then k minus 2 is the third factor, all the way down to k minus n plus 1. That's the nth factor. So there are n factors on the top. Just like what we were saying, it matches like right here. 3 factorial, so we're going to have 3 factors on top here. All right, well, let's see how we use that for example 6. For example 6, it says find the Maclaurin series for 1 over the square root of 4 minus x. Now this doesn't look right now like 1 plus x to the k, but if we can put this in the form 1 plus something to the k, then we can use this binomial series. So let's try to do a little bit of algebraic manipulation to turn this into 1 plus something to the k. Well, first off, we need that 1. And we have a 4 there. So let's factor out the 4. We've seen these kind of skills before when we talked about in 11.8. We were talking about either 11.8 or 11.9 now, I can't remember. We were talking about how to rewrite something in the form 1 over 1 minus something, because we knew that expanded into the series x to the n. Here, we're going to do the same kind of tricks. So we need that 1, and we need a plus also, so we're going to have to write this minus as plus a negative in just a moment. But first, let's take that 4 out. The square root of 4 gives you 2. So here you have 2 times the square root of 1 minus x over 4. Now this 1 over 2, we can just take out. We can write this as 1/2. And then the 1 over square root of 1 minus x to the 4th, that part we can write as a negative 1/2 power. The minus we can write as plus a negative. And now we've got something, we've got this half in front, but that's okay, that's just a constant coefficient. This part, the 1 plus negative x over 4 to the negative 1/2 power, that's matching perfectly our 1 plus x to the k. It's just that instead of an x, we have a negative x over 4. That's okay. Instead of a k, we have a negative 1/2. Well, that's what k is for. It's for being a number like that. So this is great. It matches perfectly with our function. So now we can use the binomial theorem to expand it. Oop, let me leave the binomial theorem up there so you can see it. So we have 1 over the square root of 4 minus x will be equal to, by the binomial expansion, well, we have the half out there in front, we have n equals 0 to infinity of k choose n times x to the n. So k here is negative 1/2, n is n, and then x is negative x over 4, and then n is n. N is n. Never was there a deeper statement than that. All right, so that's the summation notation version. We're going to write it out in expanded form, though. We're going to want to write a nice little expanded version of this. That'll be our goal here. So here, we're going to write the half. And then we're going to start writing it out in expanded form. Let me actually just jump up a slight little bit right here, so you can see what this expanded form is going to look like. Well, the first term is going to be 1, no matter what, so we don't have to think too hard about that one. And then we have plus. Well, here for the k, we could just write this as k over 1 factorial, just to like be interesting here and try to keep a pattern. I'm going to just do it like that. I'm going to write, here's our k. I'm going to write that as 1 factorial, so we can follow along with the pattern. And then we've got times negative x over 4 to the 1. Then we have plus. Now the next one we're going to have k times k minus 1 over 2 factorial. So here's k. K minus 1 would be negative 3/2 over 2 factorial times negative x over 4 squared. Then we have plus. Now we're going to have 3 factors on the top, negative 1/2, negative 3/2, negative 5/2 over 3 factorial. We have negative x over 4 to the 3rd. And this goes on and on, but let's just write out the first few terms. So here we're going to have a half still, and then a 1 still. So now what we can do is, I'm going to write the x to the powers off to the right, and then just focus on what those coefficients look like. And if there are any patterns, we'll leave those patterns in there, so that we don't just have numbers, but that we have some kind of sense of what the patterns are. Okay, so here we have looks like we've got a 2 that's going to appear on the bottom here, and a 4 on the bottom here. On the next one, we're going to have a 2 and another 2, and then a 4 and another 4, because it's squared. The next one, we're going to have a 2 times 2 times 2, that's like 2 cubed on the bottom, and a 4 cubed on the bottom. So let's combine the 2 cubed and the 4 cubed, and the 2 squared and the 4 squared. We're going to combine those two together. So we're going to write the 2 and the 4 here from the first one on the bottom. That's going to give you an 8. Now the negative times a negative will give you positive. That's why we wrote a positive out here. Thankfully we had it there. and then we have just an x left over, so we have 1/8 x. All right, now the next term is going to be, well, it's a negative times a negative, which is positive, and then a negative squared is positive as well, so we have a plus. We've got a 1 times 3 on the top. Let's write that as a 1 times 3 on the top. Then we have a 2 factorial on the bottom. And then we have a 2 times 2 on the top, and a 4 times 4, 2 times 2 on the bottom, and a 4 times 4 on the bottom, which would give you 8 times 8, which is 8 squared. And then we have our x squared as well. So we're just trying to simplify it, but still write it so that you can make out what the pattern is. That's what we're trying to do here. So simplify, but not too much that we can't figure out what the pattern would be, but just enough so that the patterns are kind of condensed together, like the 2 squared times the 4 squared. We can just write that as 8 squared. It's a shorter way of writing that part of the pattern. All right, so the next one, we're going to have a 1 times 3 times 5, 1 times 3 times 5 over a 3 factorial times, and then here we're going to have 3 2's here multiplied together and 3 of those 4's multiplied together. So that's 3 8's multiplied together. And then we have x to the third and so on. So this would be a nice expanded version where you can still see the pattern of what's going on, but the pattern has been simplified a little bit. So this might be a good form to leave your answer in. All right. So that's the binomial series expansion with an example. Thanks for watching this video, and see you in the next one.